The moon is a familiar sight in our night sky. It has been a source of fascination and inspiration for countless generations, appearing in myths, legends, and even guiding ancient navigators across the seas. It appears as a bright, round object, captivating our attention. Its glow can transform the darkest night into a serene and magical landscape. Sometimes it looks like a perfect circle, a full moon that lights up the entire sky. Other times it takes on a crescent shape, a delicate sliver of light that hints at the mysteries of the universe. Its presence adds beauty and wonder to the darkness. The moonlight, reflecting on a calm lake or casting shadows in a nighttime landscape, creates scenes of breathtaking tranquility. We might think the moon has its own light source. After all, it shines so brightly, especially during a full moon, but this is an illusion, a beautiful trick of nature. However, the moon does not produce any light of its own. It is, in fact, a giant mirror in the sky, reflecting the light of the sun. The light we see is actually borrowed brilliance. The moon's surface reflects the sunlight, creating the glow that we admire from Earth. To understand how the moon shines, we need to look at its relationship with the sun. The sun's rays travel through space and illuminate the moon, just as they do with Earth. The sun is a star, and like all stars, it produces enormous amounts of light and heat. This energy is what makes life on Earth possible and what gives the moon its glow. This light travels through space, illuminating everything in its path. It is a journey of millions of miles, yet it reaches us in just over 8 minutes, bringing warmth and light to our world and to our moon. The moon, unlike the sun, does not generate its own light. Instead, it acts like a giant mirror, reflecting sunlight that falls upon its surface. Imagine standing in front of a mirror with a lamp nearby. The lamp illuminates you and your reflection appears in the mirror. The moon works in a similar way. The sun acts as the lamp, bathing the moon in its light. The moon, in turn, reflects some of this sunlight back towards Earth, making it visible to us. This reflection is why we see the moon, especially at night when the sun's light is not directly illuminating our part of Earth. The moon's surface plays a crucial role in how it reflects sunlight. This reflection is not just a simple bounce back of light, it involves a complex interaction with the moon's unique topography. The moon might look smooth from afar, but it is actually covered in craters, mountains, and valleys. These features are the result of billions of years of cosmic impacts and geological activity. This rough and uneven surface is vital for scattering light in various directions. When sunlight hits the moon, it interacts with these irregularities, causing the light to scatter in multiple directions. This type of reflection, known as diffuse reflection, ensures that sunlight is not reflected in a single concentrated beam. Instead, the light is spread out, creating a soft glow that we can see from Earth. Instead, it gets bounced back in many different directions, making the moon visible from a wide range of angles on Earth. This scattering effect is what allows us to see the moon's surface illuminated, no matter where we are. If the moon had a perfectly smooth surface, like a mirror, we would only see its reflection from a very specific angle. This would make the moon appear much less bright and visible from only certain points on Earth. Thankfully, its textured surface allows us to enjoy its brilliance from almost anywhere on Earth. This widespread visibility has made the moon a constant companion in our night sky, inspiring countless cultures and generations. The moon's proximity to Earth also contributes to its apparent brightness. In the vastness of space, the moon is our closest celestial neighbor. This relatively short distance between Earth and the moon enhances its brightness in our sky. Think about looking at a street light from afar. It might seem dim. However, as you get closer, the street light appears much brighter. The same principle applies to celestial objects. The moon's closeness to us, combined with its reflective surface, makes it a prominent and easily observable object in our night sky. Section 5. The phases of reflection. Throughout the month, the moon appears to change shape. This fascinating transformation is a result of the moon's orbit around Earth, which takes approximately 29.5 days to complete. As it moves, the angle at which sunlight hits the moon changes, creating the various phases we observe from our vantage point on Earth. Sometimes it's a full circle, known as a full moon, while other times it's just a sliver, referred to as a crescent moon. These phases are not random, but follow a predictable pattern that has been observed and recorded for centuries. These different appearances are called the phases of the moon. The primary phases include the new moon, first quarter, full moon, and last quarter. Each of these phases marks a significant point in the moon's orbit around Earth. The moon's phases are not caused by changes in the moon itself, but rather by its changing position in relation to the Sun and Earth as it orbits our planet. This orbital dance creates the beautiful and ever-changing lunar display we see in the night sky. The amount of reflected sunlight we see depends on the moon's position in its orbit. When the moon is on the opposite side of Earth from the Sun, we see a full moon because the entire face of the moon is illuminated. When the moon is between the Sun and Earth, the side facing us is not illuminated by the Sun, and we see a new moon. This phase marks the beginning of the lunar cycle and is often difficult to observe due to the lack of visible light. As the moon orbits Earth, more of its illuminated surface becomes visible, leading to the waxing crescent, first quarter, and waxing gibbous phases. During these phases, the moon appears to grow larger each night, a process known as waxing, and eventually, the full moon. The full moon is a spectacular sight, often lighting up the night sky with its bright, reflective surface. This phase is followed by the waning gibbous, last quarter, and waning crescent phases, where the moon appears to shrink or wane until it becomes a new moon once again, completing the cycle. Section 6. Earth's gentle glow. Even when the moon is in its new moon phase and the side facing us is not directly illuminated by the sun, we might still notice a faint glow. This phenomenon, known as earthshine, adds another layer of fascination to the moon's appearance. Earthshine occurs when sunlight reflects off Earth's surface, atmosphere and clouds, and then bounces off the moon back towards Earth. Essentially, Earth acts as a giant mirror, reflecting sunlight onto the moon, just as the moon reflects sunlight onto us. This faint illumination of the moon during its new moon phase showcases the interconnectedness of celestial objects and the interplay of light within our solar system. Section 7. Appreciating the cosmos. Understanding why and how the moon shines allows us to appreciate the wonders of our universe on a deeper level. It reminds us that even seemingly simple observations often have fascinating scientific explanations. The moon's gentle light, borrowed from the sun and shaped by its surface and our perspective from Earth, serves as a constant reminder of the beauty and complexity of the cosmos. By exploring the science behind everyday phenomena, we open ourselves up to a greater understanding and appreciation of the world around us. Section 8. Keep exploring with us. The moon's ethereal glow has captivated humanity for millennia, inspiring countless stories, myths, and scientific inquiries. By unraveling the mysteries of the cosmos, we embark on a journey of discovery that expands our knowledge and deepens our connection to the universe. Don't forget to like this video and subscribe to our channel for more explorations of the universe and its many wonders.